Alright, today we're going to just take a quick look at a program called Air Manager. And Air Manager is, if I start it up, it's a little program to help us build 2D panels for use in Flight Simulator. In fact, I'm saying Flight Simulator, I'm going to be demonstrating this with FSX, but one of the interesting things about this program is it's cross-platform, and it's cross-platform in a couple of ways. The first thing to say is it supports Flight Simulator 10, it supports X-Plane, it supports Prepared P3D, I think both versions of P3D, so you can use it with any of those simulators. The other thing you may notice when you come to install this, that it requires Java, and that's a clue that it's multi-platform. The program itself is multi-platform. In fact, this will run on Windows, Linux, Mac, OS, and there's an iPad version under development as well. So what that means is you can build your panels and you can run them on any of those platforms. So we're just going to stick with Windows 7 and FSX for today, but you will need Java installed to run this. But that's a fairly straightforward. Once it's installed, it requires a particular version of Java. I think it needs 6.1 or something like that, and that's free. Once that's installed, this runs fine. So what do we have? Well, it's not a very inspiring user interface, but why would it be? It's kind of an Explorer display here. I'll come to some of these buttons in a minute, but you can look at the gauges that are kind of available by default. These are all stored, they're not on the computer at the moment, these are in a database on the web, and you can browse them. You'll see this button underneath each one that says Get, and if you click one of these it will download it to the computer, and we'll see that in a little while. But just looking at this catalogue of instruments that are available by default, it's fairly comprehensive, and I have to say these are really nice quality. If we just choose one and look at it, we've got a full complement of instruments for the Baron 58. This is one of them, the HSI. Very nicely done graphically, and just one thing you'll notice here, there's a little flag telling you which simulator this instrument is compatible with. This one's compatible with all three supported sims, so X-Plane, FSX, P3D. I have to say the development of this product, which is ongoing, but it has been biased fairly heavily to X-Plane. So what you find is there's more support for X-Plane in the built-in instruments. But what's quite intriguing is that an instrument can be using the same code, we'll look at the code in a while, compatible with all three simulators. That's one of the legacies really of the way this is designed. It's cross-platform from the start. I suppose a third way in which it's cross-platform, I don't know if this makes sense. It makes sense in my head. The way the instrument implementation is created, again, uses a platform-independent tool. It's actually Lua code. Now this is going to be maybe a little bit confusing if you use FSUIPC, which also has Lua scripting built in. Although the language used by the FSUIPC scripting is the same language, it's Lua 5.1, as is used by this product, Air Manager, for designing the gauge implementations. They're completely separate implementations, they just happen to use the same scripting language. So this has got nothing to do with FSUIPC, it doesn't require FSUIPC, it doesn't have any interaction with FSUIPC, so probably just worth pointing that out. What else can we say about we'll come back to the gauges. Let's just take a quick walk through this toolbar. What we're looking at here is one of a number of collections of instruments that I have set up. I have three collections set up here. I've got a Baron 58 complete panel, and so these instruments have been downloaded to my computer, and I can manipulate these as a group. I can show them all, and here they go. They come up and they're laid out in a Baron 58 appropriate configuration, and that's basically a live panel. It's running now, but it's not doing anything because FSX is not running. Now I can't really run FSX and demonstrate that easily to you because I'm using Fraps to record. As soon as I want to get FSX running, Fraps is going to try and record the FSX display. So you just got to take my word for it. So what you would do is you would run FSX, you would start up this panel. There's a plug-in program that you need to run for the simulator that you're using, so that runs, assuming FSX is on this computer, the same computer as the panel is displayed on, you would run the plugin on this computer, but most effective is to run the panel on a separate computer on the network, and that's very straightforward. If I just stop this, hang on a second. Oh god. What you'll notice here, this is you may remember I looked at a similar program called Panel Builder, and I commented that each instrument was run as a separate program. That appears to be how Air Manager works as well. So it's kind of tricky to tab through different programs in the Windows Explorer, but I'm not going to bitch about that. If I stop this panel by clicking the hide button, if we go to settings, the settings tab up here, it's a very simple setting, but at the moment it's set up for running Flight Sim on a remote computer. What we're looking at here is my desktop computer, which is where I'm editing the panels, and it's also from where I would be running the panels. So it's simply a matter of clicking on Flight Sim on remote computer. You determine the IP address and type it in here, and that's all there is to do it, and it works flawlessly. You run the plugin alongside FSX on the remote computer, and it just works. So and you can easily switch back and forward. It remembers the IP address. You'll notice that it's greyed out, but you don't have to figure that out again next time round. That's a nice little thing. Simple things like that, attention to detail. So again, you can tell it here which sim you're going to be using. We can look at individual instruments. So if we look at the altimeter, and I can show the instrument either by clicking show up there, or I think I can click the little eye, it's an eyeball or something there. I can't resize the instruments by dragging them, but if I hide it I can change parameters over here for the size and position. So what are we going to do? We're going to walk through how this works using a real world example. It's always good to use a real world example. So we're going to create a panel, but what I'm going to do is just switch over to show you this. This is my twin Otter cockpit. You're probably familiar with this if you've watched some of my previous videos, and although it's a nice cockpit and it's great fun to fly, and it makes the whole experience much more realistic, I am still stuck with this letterbox display. It's a very wide display, but it's not a very tall display. Now it looks, as you see it here, it looks fairly natural, and you might not think there's anything wrong with it, but you've got to remember this is an input only panel. So my panels, they've got lots of buttons and switches on, but they have no instruments on. So the instruments have to be viewed through that letterbox display as well. In other words, the virtual cockpit is what I have to rely on for my instruments, and this is okay because I'm using track IR, but it's a compromise. If you fly something like this, you'll realise very quickly that it's a compromise, and it's particularly intrusive on the approach and landing, because what you really want to be doing is looking out of the window, but now and again glancing down at the instruments, particularly to look at the speed, perhaps the vertical speed. And to do that with track IR, it's actually quite cumbersome and intrusive. So I had an idea of building some sort of head-up display, which you'd be familiar with from things like fighter jets, but also some of the newer airliners have head-up displays. So that's what we're going to do. We're going to create some kind of I'll elaborate this idea as we go along, but if we come back to Air Manager, we're going to create a simple panel layout that we're going to hopefully project in some clever fashion as a head-up display. Now what we could do is, in fact, let's start from scratch. Let's create the new panel from scratch, and then I'll talk it through as we go. So I'm going to go to, this may not be completely obvious here, this user interface probably could do with some work. To the right of where the cursor is now, this is all about the panel, so the group of gauges. To the left of that, it's about individual gauges. So this gauge is selected, the Cessna 152 attitude indicator. If I click, I won't click remove because it'll disappear, but if I click show, you see it. If you click hide, you see that. If I go over this side and click show, it shows the whole panel, and then I click hide, and so on, it removes the panel. So over this side is about the panel or the group of instruments. I'm going to click add to add a new panel. So we've got oh, that's interesting, I had forgotten about this. There's a number of pre-made, designed by other people, panels, so that's how I've got the Baron 58 one on my computer. But I'm going to create a blank panel group, and let's call it head-up display. and there's nothing else we need to do there. I'm just going to click add. So now we've got a blank window. Somewhere here we hope it would say head-up display. There it is, it's selected. And then I need to add instruments. Is there any configuring to be done with this? Yes, I can change the name. It's for the default aircraft. Because it's for my Twin Otter, let's just put that it's for the Twin Otter. And we'll say Twin Otter Extended. It's actually not really going to be specific for the Twin Otter Extended, but that'll do. Preferred window height. Well, now at the moment that's set to 1080 because this is running on a 1080p display. Now I'm actually going to run this in the field on a smaller display. I think it's 1280 by 720. Let's set that now. So that's an HD display, but it's 720p. I'm going to make this display, I mean we're doing it specifically for FSX, so I'm going to click FSX. I could click the compatible with P3D as well, because it's very likely that everything I do to implement this gauge is going to seamlessly work with P3D. That's not the case for X-Plane. I'm going to, if I wanted to make this compatible with X-Plane, I have to do, when we get around to writing the code. Well, anyway, we won't go into that, but I'm not going to click that. A description, well, let's just, that can be anything. Come back and edit this, if I create this and it's useful and I want to share it and I upload it to the server, I think I can do that. At some point I'll come back and put a more comprehensive description in there, but for now it's just an experiment. So what could I do? I mean, the obvious thing I could do, and which I will do as by way of experiment, is I could simply add pre-made instruments. The instruments that are shown here are not the full complement, these are just the ones I've downloaded to my PC. But I could, for example, let's say, what do I want on my HUD? Well, I want an airspeed indicator and I want a vertical speed indicator. Those are the most important things that I want. So there's the Baron vertical speed indicator, if we add that. And why don't we choose the Baron 58 airspeed gauge? That's a nice looking gauge. So if we show those, that's the VSI. You see, you can just drag them about. I'll minimize that. And in fact, dragging these about, we're creating the actual layout that we will have when the panel is running. In fact, the panel is running now, and it would be live if the plugin was running. So for now, I've got these, positioned on my main screen. The target screen, if I show you my NVIDIA control panel, you see my display setup here is the screen we're looking at is screen number 1. I have a screen over to the right which is screen number 3, and that's it's just part of my desktop. The monitor on which the panel's going to run is this small VGA monitor, which is running at 1280 by 720. When I'm happy with my panel and I'm ready to test it out, so I basically take these and drag them up to that screen. But for now, it's much easier just to have them in front of me. So we don't, what else? What we're going to do now? So we're going to hide those again. These gauges are designed around bitmap images, which are, if you look over, if I select the airspeed gauge, oops, didn't mean to turn it on. The window width and height is a square window, 512 pixels. That's a reasonable size at which to design your images. You'll see that the left and top positions are also saved here. I think that's 768 by 289. If I show that and drag it, let's try and drag it to the top left hand corner, and it snaps to that corner. You see the window behind, if you look carefully, that's greyed a little bit, but the left and top are now saved as 0 and 0, so it's tracking that as I drag it around. So you can do this methodically just by typing the numbers in there. They're greyed out there, but you have to stop the panel and then you can edit them. That's quite a good way to do it very precisely. Now something else, just this is going to be a little bit of a nag. When these gauges are live and they're running, as they are now, you can see they're displayed against the Windows desktop as the backdrop, and I've got an image displayed as my Windows desktop. And of course, if I was running my panel literally on this screen, it's a panel with the Windows desktop image in the background and icons shown as well. That's not very satisfactory. So in practice, what I tend to do is I just go to Control Panel and I set the background to be a solid color, black. And because on my target monitor there are no icons, that's fine, that works fine. So, again, you might consider that a bit of a rough edge. It would be nice if there was some, maybe there is some way that I haven't discovered yet to implement the background. But for now, we're just going to leave the Windows desktop as it is. That's the simplest way to create a head-up display for my purposes, and you might consider that that's complete. We could play with the sizes, that's again, if I stop those. But actually, if you look at other implementations of head-up displays, that's not an ideal graphical construction to try and project as unobtrusively as possible whilst giving all the information you need over the top of another display. One thing about it is it's relatively low contrast, but it's also messy. It's got all sorts of bits, these little screws and the bezels and things. That's irrelevant. We don't want to see that's going to intrude on the main display. What you want is something that's going to be diagrammatic, minimal, high contrast, and gives you all the information that you need without obscuring what it's projected on top of. So we're going to create something from scratch. So what we'll do is we'll remove those. We'll remove remember, we're going to click over this side. We're removing gauges. We're not going to remove the panel. So if I remove the airspeed gauge and the other one, whatever it was. So what we want to do, we want to go to a new tab, Create Edit. And what do we see here? We see a lot of new icons over here. These ones, let's just if you look at the tooltips, all these icons over here, they're just actually they're manual. Actually, it says there, it's underneath, it says Help. So if I click the button labeled Create, that should take us to a web page. With some information on how to create a gauge. In fact, and let's look at this shows a list of the FSX variables that are available to us. Again, it goes just to a web page. It's actually the ESP, it's the SDK documentation essentially. So that's that's very helpful. But those are just information only. So what do we have over here? Well, the only one that's available to us at the moment is New. So I'm going to click New. That allows me to create a blank instrument from scratch. I'm not going to do that. What I'm going to do is I'm going to clone an existing instrument, and it's going to show me all the instruments that I have on my computer. So what I'm actually going to do is, because the Twin Otter airspeed gauge is pretty close to the Baron 58 airspeed gauge, so we'll select the B58 airspeed gauge and we'll click Create. So I'm going to put again that it's specifically for the Twin Otter aircraft, even though really it's going to be more generic. Type airspeed gauge clone. I think we're going to call it something slightly more useful than that, so we'll call it HUD ASI. Also, I can put me in there. Version 1, preferred window width and height 512. Well, I'm presuming that has defaulted to the gauge I'm copying from, but even if it hasn't, 512 is pretty good. We'll make it a square gauge because that makes sense. Again, I'm going to click that it's compatible with Flight Simulator and not either of the other twos. And again, I'm going to put just a simple placeholder. Description. There we go. So far there's nothing to see, but if we go over to the left hand side, we'll notice that we have a new entry in the list of gauges available on the computer, and as soon as I select that, I have these new buttons available. Now the most interesting one information is what I've just filled in. So the most interesting one to investigate first is this directory. Each gauge is packaged up in its own little folder somewhere on your computer. So if I click directory is the old name for folder, you might know, and that brings up Windows Explorer. And now if you look at the path to this is in a very odd sort of thing here. It's underneath the Air Manager folder created under my user folder. So there's a folder called Instruments, and then each instrument is packaged up with that rather unreadable, that's a GUID probably, 64-bit, is it? I don't know what it is. It's some sort of machine reader, but you're not supposed to be able to find this by hand. You know, whenever you need to find this, you select it from the Air Manager interface. But anyway, underneath that folder we see three things. Logic.lua. Now we're going to come back to that later. That is the implementation. You're going to need a little bit of programming knowledge to dig around in there and customize the gauge, but we're going to look at that. Resources, if we double click on that, this is where we find the bitmaps that are used to create the gauge. They've got a suffix of PNG. You may or may not be familiar with that. It's just a raster image format, but it supports transparency. So what we have the backdrop, which, can I look at these to show icons? Yeah. You can see the backdrop is the gauge itself, which is a fairly nicely designed bitmap. We've got a little blob that goes in the center, and we've got the needle. Now you'll notice the needle and the blob, center blob, are on white background. Anything that's white, pure white, appears as transparent when it's loaded up in the live gauge. So that means you can stack these on top of each other. If we looked at some of the let me just do that. If I just park that for now, if I go and select another gauge, let me select one of the Cessna 152, choose the altimeter gauge, directory, resources. Okay, there's more than two or three bitmaps here, and what's interesting, if you look at the images supplied here, we've got the basic backdrop of the gauge. We've got the dial for the Colesman window, which is not all visible at once. If you look at this little window here, that's where the Colesman window will be displayed. So this will obviously be loaded up, but it'll be displayed in some sense behind that altitude scale, and as I said, that white window there appears transparent, so we'll see a little segment of this through there. The needles for the altimeter will be loaded up over the top and manipulated. I won't go through this in great detail, but finally we've got this thing that says scratches. So that's just a little bit of graphic design that will be loaded up at the top of the pile, and presumably it will give a sort of scratched, worn appearance to the gauge. And so when you load these up, there's a Z, or if you're familiar with the idea of a Z order or Z order if you're American, you can stack these on top of each other, and they'll mask each other appropriately. So that was just an aside. So if we go back to, let me just make sure I've got the right one selected, our new experimental HUD, Twin Otter HUD, ASI, go to the directory, go to the resources folder. If we load one of these up into a graphic editor, I'm going to use Photoshop 7 because it's what I have, we can tinker with it, and I'm not going to go through this in great laborious detail. I'm going to fast forward through. So if we fast forward, this is the completed ASI gauge. We've got the numbers are there on a layer. We've got the green arc, we've got the white arc there. The other thing I've done is I've created what I thought was, when we get to the bottom of the green, or towards the bottom of the green arc and the white arc, which coincide in the Twin Otter, I thought it'd be nice to change the display colour to give us some sort of warning of that. So I've created a layer which is yellow, and the idea is, if we save these as separate bitmaps and we swap in the yellow one when we get below, I think, let's say 70 knots, that's just another clue that we're getting towards the we don't want to go too much slower, we might end up in a stall. So basically we've got, for the implementation of this gauge, we've created three PNG files. One is the gauge background, one is a copy of the gauge background in a different colour, and finally we've got the needle. And the needle is just, if I was to drag that over, You can see the needle's just a simple line, and the idea is I can simulate that here. That sort of simulates how the gauge is going to look in action. We're basically going to rotate that bitmap that contains the needle under program control in accordance with what the airspeed is doing in the actual aircraft. So that's half the battle. But now we want to look at the logic script for implementing the gauge. Now we could this is essentially based on the original Baron 58 gauge. If I go through this executes top to bottom. So I'll just go through and there's kind of three different things it does. First thing it does is, using a couple of the Air Manager API functions, it loads up the graphic images. So these names will be familiar. These are the PNG files we just created. So we got image add, image add, image add, and then we call a thing called image rotate, which rotates the needle image to a default, to a starting value, which is minus 38 degrees, for reasons which you needn't concern yourself with. The next thing that happens is a function is defined. This function doesn't execute here. This is a function definition. Defines a piece of code, and then the line after that, in fact there's two lines here, ignore the one that says XPL, that's for explain. This line, FSX variable subscribe, this hooks us into watching the FSX airspeed indicated value, which is a value that's published by FSX. If you can read about that in the SDK documentation. And it hooks our function, the one we've just defined. This is called a callback function. And essentially, when that airspeed indicated value inside FSX changes, Air Manager arranges for our function PT airspeed to be called, with the new value of airspeed indicated as the parameter. So you can see this gauge was originally designed to be compatible with X-Plane as well. So that is the equivalent line for hooking up the callback function in X-Plane. But you'll see that apart from those two lines, the implementation of the gauge is actually the same. So again, we've got this cross-platform support. I'm not going to say too much more about this code. It's a very simple gauge. The business end of it is really this call to image rotate. It rotates the needle to a number of degrees around the gauge, simply calculated from the current airspeed. So it's simply a matter of scaling the airspeed to the size of the gauge and then moving the needle accordingly. The only wrinkle is if you remember, want to check when the speed rises above or falls below 70 knots, and then we swap in the yellow gauge below 70 for the regular gauge. So we just hide or show the image according to the current airspeed. If you look at I would encourage you to look at the code for the implementation of many of the standard gauges that you can download with this product. Some of them are very complicated indeed, and that's one of the really nice things about this product. The gauge can be as complicated as you want. I mean, it can do very ungauge-like things. You could do anything you want in this. It's just, this program is hooked into FSX and it's called in particular circumstances. You could do all sorts of clever things with it, as well as displaying images and data. But you will need some programming knowledge to do that. So what else do we want on a HUD? Well, it'd be nice to have a vertical speed indicator. So if we go new, again we'll clone an existing instrument. We might as well go and look at the Cessna 152 VSI. So again, we're gonna, if we go and look at what we get for that vertical speed indicator in the Cessna 152, you'll see I've fast forwarded. I've basically traced the gauge backdrop, and again I've created a high contrast green on black. I've changed the range available. I'll talk about that in a moment. And again, I've simplified the needle. The needle's just a green line. So that's ready to go. Just talking about the range of values that I've made available to us. It's not the range that's available in the Twin Otter. The Twin Otter goes up to, the gauge goes up to 6,000 feet per minute. But actually the reason for this HUD is we're only going to need this in critical phases of flight. During the landing, essentially, is why I'm creating this. And if we're going anywhere near 6,000 feet per minute, up or down, when we're on the approach, we're doing something drastically wrong. So I've designed this gauge really, anything over 2,000 feet per minute is clipped, and that gives us a nice sensitive gauge that we can watch. It's a good size. We'll get a good sense of movement. Once again, if we park the images and we go and look at the implementation, incidentally, we create a preview image as well, which is just, it's the same thing but with the needle in play as well, and we just put that somewhere. Well, we put it in this gauge folder, and that's what shows up in the if we select it, it's the thing that shows up here, Twin Otter HUD VSI. Anyway, back to the implementation. We go and look at logic.lua, load that up, close all those other ones. Again, it's a very simple gauge. It's a needle on a circular dial. This is a linear gauge. In fact, we're going to take a slight detour here. Originally I was going to trace the vertical speed indicator for this aircraft. It's a helicopter, Eurocopter, AS350B, I don't know what that is. But if we go and look at the resources for that, we shall see something slightly interesting. Let me just get that up in Photoshop. The reason I chose this one is it looks pretty much like the Twin Otter gauge. The numbers are slightly different, but visually it's similar. But more importantly, what's kind of interesting is if you look at the arc of the gauge, it's not linear. The markings are not linear. So we've got 0 to 1,000 is that segment there, and then 1,000 to 2,000, 2,000 to 3,000. It's not linear. This 0 to 500 and 500 to 1,000, you can actually see the tick marks are spaced differently, and that matches pretty much the format of the gauge in the Twin Otter extended virtual cockpit. In practice, to implement that in the code is slightly fiddly, and it's not really necessary to have that full arc from 0 to 6,000 feet per minute. In fact, let me just I should be able to show you. So there's the actual Twin Otter gauge. I'll try and zoom in on that. I don't know how well you're going to see this. Sorry, there it is. Vertical speed, we've got 0 to 6,000 feet per minute. Again, that first 1,000 feet occupies a greater proportion of the gauge as the next 1,000 feet, and so on. So it's a non-linear gauge. So that Eurocopter gauge would be appropriate, but it makes the implementation slightly fiddly and messy. So, and given that really we're only interested in this gauge in the last phase of the landing, if we're doing any more than 1,000 feet per minute down, we're going down too fast, and so we're only showing a 2,000 foot per minute range, plus or minus 2,000 feet per minute, and that gives us a nice, responsive, clear and accurate display, and it makes the implementation simpler. So back to the plot. So we're going to go back to the implementation of our HUD VSI. Don't worry, I've got 2 in the list here. I've been playing about with this, but if I go to the logic script, again, this is the entire implementation. So we add the gauge background, we add the needle, we define a callback function here, which is invoked whenever the vertical speed value changes within FSX, and then we hook that function up to FSX. And again, if you look up in the API, the vertical speed is the name of the variable, the units are in feet per minute, and the function name is CB new VSI. And so when that changes, we basically take the number that comes back in feet per minute, and we truncate that to 2,000 feet per minute, because that's all we can display on the gauge. So anything less than 2,000 feet per minute is displayed. Anything greater than 2,000 feet per minute or less than minus 2,000 feet per minute is clipped to that value. And then all we do is we scale that value to the visible arc, and if you go back to look at the arc, that's 180 degrees, basically half a circle. So we're scaling a number between 0 and 2000 to a number between 0 and 180. Fairly straightforward mathematics there, and then we call image rotate, and it rotates the needle to that angle, and that's all we do. And so we get a nice, responsive, simple, clear, high contrast, green on black vertical speed indicator display. So what else might we want on a HUD? Well, to cut a long story short, I went ahead and also implemented a balance ball. And I started off you know, with the idea of tracing the Cessna 152 balance ball, but in the end I made my own gauge from scratch, and essentially it is this gauge. We've got a central position and a little track with tick marks on, and then we've got a balance ball which moves around on that scale. The last thing we need to do is add that balance ball gauge into the Twin Otter HUD panel. Now if we show that panel, it's a bit jumbled up at the moment, but we can drag these things around. Just clear the background a little bit. Got a lot of windows open now. I think that's going to be, we've ended up with a gauge, the vertical speed gauge is bigger than the airspeed gauge, so we're going to need to finesse that slightly. Let me just go back into Air Manager. So we put them side by side like that. Let's put the, in fact let's move them down a bit. Again, I can't see any way to group these and move them around as a group. I might be wrong about that, but there doesn't seem to be a way to do that. And so if we move the balance ball gauge, I think we'll put that over the top. So that's pretty much what the final thing's going to look like. If I go back to my control panel, make the background a solid colour, make it black again. That vertical speed's still a little bit too big, but never mind. That's pretty much what the gauge is going to look like. So what we're going to do next is see that in action. So what I'm going to do is just move these instruments onto my external monitor. I'm going to show them. I'm going to change that to be a solid black colour. There we go. And that pretty much gives us what we need. Okay, so that's the software side of designing the HUD. Of course, we now got to get it on a head-up display. So I've got a VGA screen mounted overhead here. This is driven over the network from my desktop PC, which is where the panels will be running. Now my original idea was to take a piece of the acrylic such as the panels are built from, this very reflective material, project the display onto this and have this, because it's transparent obviously, somehow suspended in front of the main display. Now there's a couple of problems with that. The main immediate problem with that is in practice the contrast of the display once it's reflected off this material is simply not enough. It's just washed out. You can barely see it against, you can see it against, if it's suspended in front of a dark piece of the panel, or indeed one of my own dark coloured hardware panels, it's very readable and very satisfactory. But once it's in front of sky or terrain, yeah, outside the window view, which is exactly where you need it of course, the contrast isn't sufficient. So plan B was to take a piece of acrylic and suspend it somewhere else that's within easy viewing distance, and there's various options for where you could do that. But even if the contrast had been sufficient, there was another problem became immediately apparent. But even if the contrast had been sufficient, there was another problem which was immediately apparent when I tried to view a reflection in this material, and that is you get two reflections. You get a reflection from the front plane of the acrylic, and also you appear to get a reflection from the rear plane, and so in practice you get a double image and it just looks fuzzy, and there's no real way around that whilst preserving the transparency. The only way around that is to take a piece of sandpaper and roughen the rear surface. So I've done that, piece of fine sandpaper just roughened the surface, so you then still have a shiny front surface. I'm not sure if you can see this in the video, and you still get a very good reflection from it, but you don't get a reflection from the rear surface. And the problem with that obviously is you can no longer see through the HUD. So if it was
going to be suspended in front of the display. Obviously it's not going to work. Presumably there's some way to get around that in designing a real HUD, because these things do exist. Thinner glass, thicker glass, special surface treatments or something, I don't know. But for now we're stuck with having to put the HUD somewhere outside of the main field of view. Now there's plenty of opportunities for that. I did experiment with putting it in front of one of my overhead panels, putting it up here, but I've arrived at a compromise, which is putting it pretty much somewhere down here on the main panel where the real instruments probably would be. And I've got as you can see, that I've got a flip down HUD effectively now, and well, you know, it's not ideally situated. It's there for experimental purposes at the moment. I mean, it covers the autopilot controls, but it's in a good place for just glancing down on the approach. Hopefully we're going to be able to get a look at that in action